This is an extra example out of section 3.1. I thought we could do this problem 48 here that I've pointed to, finding the absolute max and absolute minimum values of the function f on this given interval. The function is x cubed minus 6x squared plus 5. The interval is from -3 to 5. So we've got f of x equals x cubed minus 6x squared plus 5 on the interval from -3 to 5. If you remember from the problems we did in the video there, we want to start by finding critical numbers. So we're going to take the derivative. This one's a pretty easy polynomial derivative here. X cubed becomes 3x squared. Minus 6x squared becomes minus 12x. That plus 5 goes to 0, so there's our derivative. And we're going to set this derivative equal to 0. That was my baby girl in the background there. All right, so we're going to set the derivative equal to 0 to find critical numbers. Not a hard algebra problem now. I could just factor a 3x out, and I'm left with x minus 4. So we've got critical numbers of 0, because we could have x equals 0, or x equals 4. Now, one thing to point out, both of those are in our intervals, so those are both relevant points. Okay, so we're going to check. Now, notice we know the derivative is 0 at these two critical numbers. What we don't know is the actual value of the function. So we're going to plug these two values into the function, and then we're going to check the endpoints. Whatever our maximum is, that's our absolute max. Whatever our minimum is, that's our absolute minimum. All right, so scrolling up here, let's see. F of 0. I suppose I could rewrite down f here. So f is x cubed minus 6x squared plus 5. So f of 0 is 5. F of 4 is, let's see, 4 cubed is 64, minus 6 times 16. Let's see, 6 times 16 puts us at 96, plus 5. So 69 minus 96, we're at 27 there. Excuse me, negative 27. Okay, those are our two critical numbers. All right, then our endpoints were -3 and 5. So let's see, f of -3 equals negative 27 minus 6 times 9, so minus a 54 plus 5. So that comes out to negative 81 plus 5. That's a negative 76. And then f of 5 is, what did we have here? 5 cubed, that's 125. Minus 6 times 25, that's 150. Plus 5, so we get a negative 20 out of that. Okay, so what happens on these sorts of problems is you end up with 4 possible numbers. In this case, 2 endpoints, 2 critical numbers, although you could have any number of critical numbers. But in this case, you have 4 possible values that are your max or your min. We have 3 negative values and 1 positive value. You see our positive value then's got to be the maximum. And then whatever's most negative is our minimum. All right. So to complete this problem, I would say f of x has an absolute max of 5 at x equals 0 and an absolute minimum of negative 76 at x equals -3. And there's our problem.